YouTube. Just type in VK3CSJ in the YouTube search engine and look for the live indicator. And we also have an email address, vk3ekh@gmail.com, vk3ekh@gmail.com for any signal reports and the like. And also a Discord chat room. Just install Discord. We'll go to your search engine, type in Discord and install Discord free of charge, and then look for or search for Astronomy chat room, and you should be able to find the ASC radio link connection to the chat room. I hope the audio level, I've just got to keep an eye on my audio level on the vMix here so that I don't distort YouTube. I noticed that last week it was just, each time I clipped into the red, it was just making a little bit of distortion on YouTube, which is a bit of a nuisance factor. So I'm going to try and keep that down, and I might, the audio level on 80 though has dropped as a result of that. Let's see if I can just bring up that audio level on 80. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Hopefully that won't affect the stream. 1, 2, 3, 4. 4. Okay, it should hopefully be okay for 80. It's a separate gain controller for that, and keeping vMix in control as well. So yes, I'll keep an eye on things there. I was hoping tonight to also run a HD video on Discord. I'm still getting used to it. Just last weekend I mucked around with running a HD video signal on the Discord side of things, which you can do. The advantage of that is that the delay from listening to me here live on 80 meters and also catching up with the video side of tonight's production is less than a second. Thank you, Richard. All right. So I've actually paid for the ability to run HD on Discord, and in experimenting with it last week, it actually worked okay. Had some success with it, but there is a bit of a trick in running it with vMix. It can be done, and I did play around with that a little bit earlier on, Richard, but vMix locked up. The couple of times that I tried to muck around with it, the vMix locked up. So there was a part of the procedure I didn't quite have right, and didn't get around to working that out because I started to collect articles to read out tonight, which is quite a few of. I'll fill up the hour without a problem. Anyway, but next week we will have a video channel running in the Discord medium format, and that'll, as I say, the video will be like I say, within a second of what I'm talking about on 80 meters, as opposed to the YouTube channel, which is some 20 seconds later, which I know frustrates everybody that doesn't have access to the RTV repeater. Even ATV repeater, there's a delay due to the digital processors, but it's far better than what you see on YouTube. So I only provide the YouTube stream mainly because of the visual aspect of the Friday night broadcast, nothing else, no other reason. So you won't get me, saying subscribe or click here and click there on YouTube. I'm not worried about all that crap. Anyway, you're tuned to VK3 Echo Kilo Hotel, the official station again of the Astronomical Society of Victoria, with a Friday night broadcast on this 24th of May, nearly the end of the month, and it's going so quick. It's just a shocker. It really is a shocker. Okay, now I'm just going to quickly check my email to see if anybody has reported in thus far. And at this stage we have Wayne. It's called in. He says that the band is noisy tonight, however signals are strong. hearing all kinds of stuff about the frequencies. He says, you are a good signal into the west tonight. Audio is okay. Thank you, Wayne. Excellent to know. Okay, right. Hearing a funny noise over there in the far corner. I'm not sure what that is. All right. Okay. All right, I'll catch up with that. Stephen has also sent me an email, Mr. SPX, and he says that I'm 25 over 9, maybe a few dB less than usual. Yeah, well, I'm keeping it down on 80 just because of the fact that I can get into my modem. So there it is. Thanks, Steve. And Mr. Lewis has sent me an email, and he says, what does he say? He's got all this other stuff associated with his email. It's so confusing, Mr. Lewis. He says, evening, Clint. He says, when you made the changes... Oh, hang on. Just a sec. I've got to... Thank you. I've just reduced my bass. Thank you for reminding me, even though you didn't say anything yet that I've read. Anyway, I've just knocked the EQ, bass EQ down, so that might be a bit better. When you made the changes to levels, you introduced some slight distortion to your 80 meter signal. It was fine before the adjustment. I've only reduced things, I didn't increase things. Oh, actually, I did. I increased the on 80 meters. Anyway, I've just knocked the EQ down on the bass side of things, so that might make things a tad better on the 80 meter side too. You might like to just quickly indicate that, Mr. Lewis. Discord, a quick look on Discord. No, it's the messenger. Where's my Discord? There it is. And currently we have Kim, VK5 FUSE, Richard, VK3 VRS, Steve, VK3 SPX, and that's about it on the Discord chat room. And yes, I won't start mucking around with the video side of it. I'll just stuff things up right now. So I'll minimize that Discord screen, and I'll minimize my email and get into things at 7 minutes past the hour. Alrighty then. Oops. So, my glasses aren't working for me at close-up range. It's a pain. The Astronomical Society of Victoria, founded 1922, has well over 1,600 members scattered about Victoria and Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, with the latter being held on a Saturday night. Meeting starts at 8 p.m. at the Mullier Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located not too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Dells Brooks Drive, and the surrounding streets. Admission is free, and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV's magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory and are accessible as well. The Society also has a number of 200mm reflectors available for short period loan, so members can buy before they try. Regular Society Club Night meetings are held at the Melbourne Observatory in the Ellery Suite in Burwood Avenue, opposite the Shrine of Remembrance. Members are encouraged to use the Society's instruments located there to gain first-hand experience in telescope use. These instruments include a 508mm equatorial reflector and a number of smaller reflectors. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90 minutes drive north of Melbourne. There are a range of instruments available for members to use there, the larger with appropriate training, and they range from 300mm to 1000mm in aperture. Also located on the site is a fully steerable 8.5 metre radio telescope, which members can access with involvement in the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same thing. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that the members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology, and astrophysics, historical studies, research, and astronomy in general. Contact details for various section directors can be found in the yearbook. Further information may be obtained by visiting the ASV website, and notification of events are given in the Crux Extra Bulletin sent out via email to members. Please note that the ASV will conform to all government health directives. Thus, ASV events may be required to be cancelled, moved or postponed. If you wish to write a letter to the Secretary, or that is a letter to the ASV, you can send it or address it to the Secretary, Astronomical Society Victoria, GPO Box 1059, Melbourne, Victoria 3001. That's the Secretary, Astronomical Society Victoria, GPO Box 1059, Melbourne, Victoria 3001. Otherwise, you can visit the ASV website at www.asv.org.au, www.asv.org.au, and all will be revealed. You're tuned to ASV Radio, VK3EKH, the official station of the Astronomical Society of Victoria. In fact, I should be able to run one of those little announcements here. I've got that all queued up. Yeah, I think I have to press that button to do that. Oops, that was a funny noise. What did that? All sorts of noise occurred when I did that. That was unusual. Oh, why did I do that? That's not going to work if it's going to do that. Oh, okay. Why is it doing that? Well, let's just see what happens if I press this button anyway.
You're tuned to VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South.
Oh, okay. Well, it didn't sound too good for some reason. Not sure the reason for that. Anyway, alright. It's always something here on a Friday night that upsets the roll of things. Okay, let's get a move along, a jig along. 1, 2, I can hear myself coming through somewhere here. There's something, one of these external speakers is making noises. I can hear it. It's a rather nuisance, that is. Oh, I think I had my monitor on. Oh, maybe that was why. Hang on. No, it's still doing it. Oh, jeez. It's sent to try me. Okay. Let me see. The first article tonight. It's an Ask Astro article, courtesy of astronomy.com. And we just have the one image here that I can bring up in association with this article. Nothing much really to speak of. Let me just make sure it's the right picture. Yeah, I think that's it. And I'll bring that across and see if I can insert my own picture here. Nope, not that one. No, that's certainly not what I wanted. Right. Why is that coming up now? Oh my goodness me. It's all happening. Trying to get the video sorted out. Oh, I'm clicking on the wrong thing. No wonder. That's what I wanted. And now I've lost my logo at the bottom of the screen here. And this one here I want. And stop disappearing on me. Bloody vMix, I tell you, it's stirring me up tonight. Thank you. And that's all I wanted from a visual. It's just the video side that's going on here. So if you're watching the vision side of it, you can understand what's just been going on. Wouldn't it bother you? All right. Now, getting back to the article. Let me just check one thing. 1, 2, 3. Yep, just making sure that level and VMix is all right. How do scientists weigh planets and other celestial objects? You have often heard astronomers referring to the weight, or how much a galaxy weighs, or something of that nature. Something that's a little bit unfathomable to imagine how they must do that. Anyway, let's see if this article addresses it, because I haven't really read it through yet, but I'm sure it's going to address it. And the picture on the screen at the moment, the article here says that there isn't a scale large enough to weigh galaxies like the NGC 7714, and that's what that picture is there, NGC 7714. Anyway, how do scientists weigh celestial objects? It's true that you can't simply place a planet or galaxy on a scale to measure how heavy it is. Luckily, astronomers have a few tricks up their sleeves. Collective sleeves. The first trick is understanding that gravity and mass are inherently linked. It's important to note that weight, which measures the strength of your local gravitational pull on an object, can change, while mass does not. For example, if you step on a scale on Earth and weigh 150 pounds or 68 kilograms, that same scale would read 379 pounds or 172 kilograms on Jupiter. For your personal mass isn't what's changing, but your weight changes because more massive planets exert greater gravitational pull on you than less massive ones. So, to find the mass of an object, astronomers can simply look at how long it takes nearby bodies to orbit that object. Provided they know the distance between the bodies, they can calculate the mass of the central body. In the case of binary stars, astronomers can observe the stars orbiting each other to determine their combined mass. If the stars are nearby and astronomers can see how closely each star orbits their companion, their common centre of mass, they can determine each star's individual mass. For galaxies, it's a little different, but by examining how fast a galaxy is rotating, researchers can similarly determine its mass. There's another common trick astronomers can use to estimate mass: luminosity. In most cases, a star or galaxy's luminosity, how brightly it shines, is roughly proportional to its mass. So, provided you know one, you can solve for the other. In the case of stars, scientists use computer simulations of how these objects evolved to better understand the relationship between a star's mass and its luminosity, as well as other parameters that can be observed, like temperature and its composition. That's what I like. Nice and quick articles. Alright. Get back to me there and get rid of that. Alright. So, there it is. In a nutshell, how they weigh planets. It's all to do with astrophysics. You got it? What, on YouTube? Oh, on 80 metres, is it? Why is it on 8 metres overdriven? Alright, I'll knock that back. 1, 2, 3, 4, 5. How's that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is it better on 80? Oh, okay. Don't know why that would be. Alright, just knocking back the level on 80 again to approximately where it was. I haven't upset the modem though. Okay. Next. Let's just have a quick look at email. Got an email from Dave there. G'day Dave, haven't heard from you for a while. Weekly broadcast loud and clear on YouTube. Excellent stuff. Thank you, dear sir. Next article. Stop with the arms, Clint. Exoplanet. Yes, more exoplanets are being discovered. And there's an artist's impression here, so I shall throw that up on the screen. Where is it? Is that it? Yeah, that's it. Did have it. Okay, hang on a sec. Lads, there we are. Alright, so, thank you. Just getting things right here. There's a new exoplanet discovered in a habitable zone of a multi-star system. This is May 17, published May 17, astronomy.com. This Neptune-like world orbits the Sun like a star in a binary system where conditions are right for liquid water to remain on its surface. A team of professional and citizen scientists has found a Neptune-like exoplanet orbiting one of two Sun-like stars in a binary system. The planet, dubbed TOI 4633c and nicknamed Percival, was identified using data from NASA's Transiting Exoplanet Survey Satellite, or TESS. The exoplanet was spotted when it passed in front of its host star, TOI 4633a, temporarily dimming its light like a solar eclipse. The find, published in the Astrophysical Journal, might help astrophysicists understand how planets form around and orbit multi-star systems, opening the door to even more places we can search for exoplanets. Finding planets in multi-star systems is crucial for our understanding of how you can make different planets out of the same material, said study first author Nora Isner, a researcher at the Flatiron Institute's Center for Computational Astrophysics, in a press release. Anyone, this is citizen science now, anyone with internet access can easily take part in the online Planet Hunters test program, which is part of the larger Zooniverse platform. Oftentimes in science, people are better at spotting certain patterns than computers. In the case of exoplanets, this is true when it comes to exoplanets with long orbits. Human volunteers are more likely to flag these than an algorithm which finds such signals harder to identify. About 43,000 citizen scientists worldwide have aided researchers in cataloguing 25 million different objects as part of the project, including TOI 4633c. 15 volunteers noticed the new exoplanet in the data they were examining, so Isner and her team decided to take a closer look at it. They identified small wobbles in the host star, a sign that another star or object is orbiting, another planet or object is orbiting closer to the star. To confirm if this was the case, the team looked at archival data covering nearly 120 years to discover that the object causing the wobbles was another star, now named TOI 4633b. It orbits TOI 4633a every 230 years. And there's a graphic I'm going to bring up here as part of this article. I've I've got so much going on here. There it is. Just about 4 lines in my vMix. It's a lot of stuff. All right. There it is. Okay, back to the article. Right, so so it orbits TOI 4633A every 230 years. The graphic on the screen at the moment, they're saying here that the TOI 4633 star system contains 2 Sun-like stars, a Neptune-like exoplanet, and a second unconfirmed Jupiter-like world. And that little text is about that, all that. So, to continue on, the newly discovered exoplanet takes about 272 days to complete one revolution around TOI 4633A. It is located in the star's habitable zone, the region around a star where temperatures allow a planet to host liquid water on its surface. This means TOI 4633A, the brightest star yet known to hold a planet in its habitable zone. However, you could not walk on the exoplanet because it has no solid surface. But if, say, TOI 4633C had a rocky moon, that could potentially support life on its solid surface, the researchers said. A study from 2017 published in Nature Communications found that Earth-like planets in binary systems could be habitable if they orbited at the right distance. The research was based on models of the Kepler-35 system, where 2 stars host a Saturn-like planet. Stars form when cold interstellar gas and dust gathers and collapses. Planets are formed from the leftovers of this process. In many cases, there is enough gas and dust to form 2 or more stars at once, which means astronomers expect that exoplanets with 2 suns are not uncommon. If we were able to constrain where the planets orbit, it would really offer a stepping stone to open up our understanding of exoplanet formation. Eastner said it could also possibly help us someday be able to look at a star and its properties and make some guesses about what planets are potentially orbiting in that system. Okay. Let me just pick up my camera and get rid of that. Alright, you're tuned to VK3 EKH, ASV Radio, the regular Friday night broadcast. Next, now this is interesting. This is published April 15, so it's a few weeks ago, but I'm only just discovering this article. Okay. Courtesy of astronomy.com, published 15th of April. Title of the article is "These Are the Clever Messages Headed to Jupiter Aboard NASA's Europa Clipper." And of course, anything to do with Carl Sagan, I'll be quite happy to read. Carl Sagan and Frank Drake are among the inspirations for the difficult task of communicating across the vast times and space. And there's a picture there. I'll just bring this image up of this thing, this plate. Bring it there. Okay, have a look at that. NASA's Europa Clipper spacecraft headed to Jupiter ice-covered moon Europa in October 2024 will carry a laser-etched message that celebrates humanity's connection to water. The message pays homage to past NASA missions that carried similar messages. As the president of Messaging Extraterrestrial Intelligence, or METI, METI International, I helped design, not me the author, I helped design the message on Clipper with two fellow members of our board of directors, linguists Cheryl Wells Jensen and Laura Bazard-Walsher. METI International is a scientific organisation dedicated to transmitting powerful radio messages to extraterrestrial life. We collected audio recordings in 103 languages, and we decided how to convert these into waveforms that show these sounds visually. Colleagues. My dyslexia coming through there. Colleagues, not Kellogg's. Colleagues from NASA etched these waveforms into the metal plate that shields the spacecraft's sensitive electronics from the Jupiter harsh radiation. I also designed another part of the message that usually or visually depicts the wavelengths of water's constitutes, because water is so important to the search for intelligent life in the universe. Etching messages into spacecraft isn't a new practice, and Clipper's message fits into a decades-old tradition started by astronomer Carl Sagan. In 1972 and 1973, two Pioneer spacecraft headed to Jupiter and Saturn carrying metal plaques engraved with scientific and pictorial messages. In 1977, two Voyager spacecraft headed to Jupiter, Saturn, Uranus and Neptune bearing gold-plated copper phonograph records. These records contain tutorials in mathematics and chemistry, as well as music, photos, and sounds of Earth, and greetings in 55 languages. As water is essential for life on Earth, searching for its presence elsewhere has been key to many NASA missions. Astronomers suspect that Europa, where Clipper is headed, has an ocean underneath its icy surface, making it a prime candidate for search for life in the outer solar system. Part of the Clipper message features the word for water in 103 languages. We started with audio files collected online, but we then needed to analyze those and find an output that could be engraved on a metal plate. I ended up going back to some of the techniques I used in some of my early psycholinguistic research, where I explored how emotions are encoded in speech. 103 spoken words are represented a global snapshot of the diversity of Earth's languages. The outward-facing side of Clipper's plate shows the words as waveforms that track the varying intensity of sound as each word is spoken. Each person whom we recorded saying the word water for the waveform had a connection to water. For example, the lawyer who contributed to the word for water in Uzbek, SUV, S-U-V, or SUV, I guess, or organizes an annual music festival in Uzbekistan to raise awareness of the desertification of the Aral Sea. The native speaker of the Catalan water word is Yuga, hunts for exoplanets, discovering potential habitable planets that orbit other stars. And here's another image, which the article's about to continue on with. This is the other side of the plate. On the other side of the plate, the Drake equation is inscribed at the top of the inward-facing side of the plate bearing the Clipper message. It is written in Frank Drake's handwriting. Clipper's message also pays homage to astronomer Frank Drake, the father of SETI, the search for extraterrestrial intelligence, by bearing the Drake equation, the namesake formula. By drawing on scientific data, as well as some best guess hunches, the Drake equation estimates the number of extraterrestrial civilizations in the galaxy currently sending messages into the cosmos. By one widely quoted estimate, there are a tenth as many of these extraterrestrial civilizations as one's average lifetime in years. If civilizations survive for 1,000,000 years, for example, there should be about 100,000 in the galaxy. If they last only a century on average, scientists would estimate that about 10 exist. Radio astronomers study the universe by examining the radiation that chemical elements in space give off. They spend much of their time mapping the distribution of most abundant chemical in the universe, hydrogen. Hydrogen emits radiation at a certain frequency called the hydrogen line, which radio telescopes can detect. During Project Ozma, the first modern-day SETI experiment, Drake looked for artificial signals at the same frequency because he figured scientists on other worlds might recognize hydrogen as a universally significant and broadcast signals at that frequency. And there's another part of this image here. On screen at the moment, the inward-facing side of the Europa Clipper message includes wavelengths of hydrogen and hydroxyl emission lines. These represent the components of water. The band of frequencies between these lines is called the water hole. The water hole. As our team developed our water words message, I realized, the author, that the message would only make sense if it were discovered by someone already familiar with the content inscribed on the plate. The Drake equation would only make sense if someone already knew what each of the terms in the equation stood for, of course. The Europa Clipper will crash into Jupiter or one of its other moons, with Ganymede or Callisto the leading candidates. But if for some reason the mission changes and survives that fate, then humans far into the future with radically different cultural background and different language conventions may retrieve it millennia from now as an ancient artifact. To ensure we had at least one part of the message that a distant future scientist might be able to understand, I also designed a pictorial representation of the same frequency that Drake used for Project Ozma, the hydrogen line. We engraved this on the Clipper plate along with a frequency called the hydroxyl line, which you can see on the screen there. When hydrogen and hydroxyl combine, they form water. Scientists call the range of frequencies between these lines the water hole. The water hole represents the part of the radio spectrum where astronomers conduct the first SETI experiments. We displayed the hydrogen and hydroxyl lines using the wavelengths in the Clipper message. The metal plate also has diagrams showing what hydrogen and hydroxyl look like at the atomic level. We're hoping that future chemists would recognize these chemical components as the ingredients of water. If they do, we will have succeeded in communicating at least a few core scientific concepts across time, space, and language. Waveforms let our team tie messages on the two sides of the Clipper plate together. On the water words side, over 100 words are depicted by their waveforms. On the other side, the wavelengths of hydrogen and hydroxyl, the constituents of water, are etched into the plate. METI International funded the collection and curation of the water words, as well as my design of the hydrogen and hydroxyl lines, providing these two to NASA at no cost. While designing the message for the Europa Clipper, we got to reflect on the importance of water on Earth and think about why astronomers feel so compelled to search for it beneath the icy crust of Jupiter's moon Europa. The spacecraft is scheduled to enter Jupiter's orbit in April 2030. So it'll be launching in October this year. Interesting. Looking forward to seeing how successful that will be. There was a video I was going to play associated with that article, but I'm just a bit afraid that it won't come across 80 meters very well because of that problem I've got. I don't know why that's so noisy. It's got an unusual thing going on there. Alright, I'll have to worry about that later. Okay. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, where the time is 19 minutes to 11. Okay, this article from sciencealert.com, and we have a bit of a graphic there. Okay, let me see. Hundreds of huge stars disappeared from the sky. We may finally know why. 24th May 2024 by Michelle Starr, Science Alert. And the image on the screen is an artist's impression of VFTS 243. Well, let's get into the article. Am I still streaming? I'm just checking this. Yep, still streaming. When massive stars die... Oh, just before I carry on, I forgot to mention that Richard, VK3VRS, is streaming to Discord my vision. He's taking the video feed off the repeater directly, and he's feeding... There is a feed on the Discord channel, so if you are connected to Discord, you can view the visions, not in HD though, I might add, but there is visions running on Discord which you should be able to click on. When massive stars die, we understand that the universe, they don't go quietly. As we understand the universe, they don't go quietly. As their fuel runs out, they become unstable, wrecked by explosions before finally ending their lives in a spectacular supernova. But some massive stars, scientists have found, have simply vanished, leaving no trace in the night sky. Stars clearly seen in older surveys are inexplicably absent from newer ones. That's interesting. A star isn't exactly a set of keys. You can't just lose it down the back of the couch. So where the heck do these stars go? A new study has given us most compelling explanation yet. Some massive stars suggest that international team led by astrophysicist Langenero, that person, of Denmark, and Max Planck Institute of Astrophysics in Germany can die, not with a bang after all, but a whimper. Their evidence, a binary system named VFTS 243 in the Large Magellanic Cloud, consisting of a black hole and a companion star. This system shows no signs of a supernova explosion that, according to our models, ought to have accompanied the formation of a black hole. And there's another graphic here I can bring up, part of this article. This graphic on the screen right now is a not-to-scale artist's impression of the VFTS 243 system and its home in the Tarantula Nebula. Continuing on. Were one to stand gazing up at a visible star going through a total collapse, it might, just at the right time, be like watching a star suddenly extinguish and disappear from the heavens. The collapse is so complete that no explosion occurs, nothing escapes, and one wouldn't see any bright supernova in the night sky. Astronomers have actually observed the sudden disappearance of brightly shining stars in recent times. We cannot be sure of a connection, but the results we have obtained from analysing VFTS 243 has brought us much closer to a credible explanation. When a star more massive than about 8 times the mass of the Sun goes supernova, it's extremely messy. The outer layers, most of the star's mass, are explosively ejected into space around the star, where they form a huge expanding cloud of dust and gas that lingers for hundreds of thousands of millions of years. Meanwhile, the star's core, no longer supported by the outward pressure of fusion, collapses under gravity to form an ultra-dense object, a neutron star, or a black hole, depending on the initial star's mass. These collapsed cores don't always stay put. If the supernova explosion is lopsided, this can punt the core off into space in a natal kick. We can also sometimes trace the core's trajectory back to the cloud of material it ejected as it died, but if enough time has elapsed, the material may have dissipated, but the signs of the natal kick can remain a lot longer. And there's a little GIF image here I can play. It should, which one is it? This one here. Okay, and I'll put it on a loop. Alright, okay. VFTS243 is a very interesting system. It consists of a massive star that's around 7.4 million years old and around 25 times the mass of the Sun, our Sun, and a black hole around 10 times the mass of the Sun. Although we can't see the black hole directly, we can measure it based on the orbital motion of its companion star, and of course we can infer other things about the system. One interesting thing is the shape of the orbit. It's almost circular. This, however, or this together with the motion of the system in space, suggests that the black hole did not receive a huge kick from a supernova. The researchers who discovered the black hole back in 2022 suspected as much. Now, the work of Virginia Gomez and his colleagues have confirmed it. There has been a growing body of evidence that suggests that sometimes massive stars can collapse directly into black holes without passing supernova or collecting 200 space dollars. VFTS243 represents the best evidence we have for this scenario to date. Our results highlight VFTS243 as the best observable case so far for the theory of stellar black holes formed through total collapse, where the supernova explosion fails, and which our models have shown it to be possible. It is an important reality check for these models, and we certainly expect that the system will serve as a crucial benchmark for future research in stellar evolutions and collapse. The research has been published in physical review journals. Well, that's an interesting one. Imagine observing a star and it just suddenly disappears from the screen. Rather amazing stuff. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Astronomical Society of Australia is what I was going to say. Now, this article is a bit lengthy, and I don't know if I'll go through all of it because it's a bit of an update on Voyager, and I'll bring up the image here I have of Voyager. There it is. Well, I think we've all seen Voyager before. There it is. That's what it looks like. Things are finally looking up for the Voyager 1 interstellar spacecraft, published just 22 hours ago by Monisha Reveseti. Monisha Reveseti. And yes, the picture on the screen is Voyager 1 with the sun in the background. Anyway, the author says, it's always tricky when the author writes like she's talking to you. I was once sitting with my father while Googling how far away various things in the solar system are from Earth. He was looking for exact numbers and very obviously grew more invested with each new figure I shouted out. I was thrilled. The moon, on average, at 238,855 miles, or 384,400 kilometres away, the James Webb Space Telescope bumped that up to about 1,609,344 kilometres away. Then the Sun, of course, at 93 million miles, or almost 150 million kilometres away. What about Neptune? 2.8 billion miles, or 4.5 billion kilometres away. Well, wait until you hear about Voyager 1, I eventually said, assuming he was aware of what was coming, and he was not. NASA's Voyager 1 interstellar spacecraft actually isn't even in the solar system anymore, I announced. Nope, it's more than 15 billion miles, or 24 billion kilometres away from us, and it's getting even farther as we speak. I can't quite remember his response, but I do indeed recall an expression of sheer disbelief. There were immediate inquiries about how that's even physically possible. There were bewildering laughs, different ways of saying wow, and mostly there was a contagious sense of awe. And just like that, a new Voyager 1 fan was born. It is easy to see why Voyager 1 is among the most beloved robotic space explorers we have, and it is thus easy to understand why so many people felt a pang to their hearts several months ago when Voyager 1 stopped talking to us. For reasons unknown at the time, the spacecraft began sending back gibberish in place of neatly organised of data-rich zeros and ones it had been providing since its launch in 1977. It was this classic computer language which allowed Voyager 1 to converse with its creators while earning the title of the farthest human-made object. It's how the spacecraft relayed vital insight that led to the discovery of the new Jovian moons, and thanks to this sort of binary podcast, scientists incredibly identified a new ring of Saturn and created the solar system's first and only family portrait. This code, in essence, is crucial to Voyager 1's very being. Plus, to make matters worse, the issue behind the glitch turned out to be associated with the craft's flight data system, which is literally the system that transmits information about Voyager 1's health so scientists can correct any issues that arise. Issues like this one. Furthermore, because the spacecraft's immense distance from its operators on Earth, it takes about 22.5 hours for a transmission to reach the spacecraft and then 22.5 hours to receive a transmission back. Alas, things weren't looking good for a while, for about 5 months to be precise. But then on April 20, Voyager 1 finally phoned home with legible zeros and legible ones. The team had gathered early on a weekend morning to see whether telemetry would return. Bob Rasmussen, a member of the Voyager flight team, told Space.com, "It was nice to have everyone assembled in one place like this to share in a moment of learning that our efforts had been successful. Our cheer was both for the intrepid spacecraft and for the camaraderie that enabled its recovery." And then, on May 22, Voyager scientists released the welcome announcement that the spacecraft had successfully resumed returning science data from 2 of its 4 instruments, the plasma wave subsystem and the magnetometer instrument. They are now working on getting the other 2, the cosmic ray subsystem and low energy charged particle instrument, back online as well. Though there technically are 6 other instruments on board Voyager, those had been out of commission for some time. The comeback. Rasmussen was actually a member of the Voyager team in the 1970s, having worked on the project as a computer engineer before leaving for other missions including Cassini, which launched the spacecraft that taught us almost everything we currently know about Saturn. In 2022, however, he returned to the Voyager because of a separate dilemma with the mission and has remained on the team ever since. There are many of the original people who were there when Voyager was launched, or even before, who were part of both the flight team and the science team. Linda Splicker, a planetary scientist at NASA's Jet Propulsion Laboratory, also worked on the Voyager mission, told Space.com in This Week from Space podcast on the TWIT network. It's a real tribute to Voyager, the longevity not only for the spacecraft but for the people on the team. To get Voyager 1 back online in rather cinematic fashion, the team devised a complex workaround that prompted the FDS to send a copy of its memory back to Earth. Within the memory readout, operators managed to discover the crux of the problem, a corrupted code spanning a single chip, which has then remedied through another honestly super interesting process to modify the code. On the day Voyager 1 finally spoke again, you could have heard a pin drop in the room, Splicker said. It was very silent. Everybody's looking at the screen, waiting and watching. Of course, Splicker, who brought in some peanuts for the team to munch on, but not just any peanuts. They were the lucky peanuts. It's a long-standing tradition at JPL to have a peanut feast before major mission events like launches, milestones, and the possible resurrection of Voyager 1. It began in the 1960s when the agency was trying to launch the Ranger 7 mission that was meant to take pictures of and collect data about the moon's surface. Rangers 1 through 6 had all failed, so Ranger 7 was a big deal. As such, the mission's trajectory engineer, Dick Wallace, brought lots of peanuts for the team to nibble on and relax. Sure enough, Ranger 7 was a success, and as Wallace once said, the rest is history. So Voyager 1 needed some of those positive, snacky vibes. It's been 5 months since we've had any information, Splicker explained, so in this room of silence, besides peanut-eating noises, Voyager 1 operators sat at their respective system screens just simply waiting. All of a sudden, it started to populate. The data, Spiker said, that's when the programmers who had been staring at the screens in anticipation leapt out of their seats and began to cheer. And they were the happiest people in the room, he says that he thinks, and this was just a sense of joy that had Voyager 1 back. And I've got a little picture of that little moment amongst the team as well. Alright, now there's a little bit more to this article, but I won't continue it because it's already coming up to 11 o'clock, I can see. If you want to follow that up a bit more, it's space.com, the website space.com, and looking under space exploration, things are finally looking up for the Voyager 1 interstellar spacecraft. Alright, excuse me, I was just going to give a quick plug for astrophys.com, astrophys.com, and where's my slide for that? Okay, the latest podcast from Brendan O'Brien. Dr. Marcus Lower talks about pulsars stripped bare. He says, Brendan says that today we're speaking with Dr. Marcus Lower, who is a postdoctoral fellow at Australia's National Science Agency. His research primarily focuses on pulsars, rapidly rotating neutron stars that emit beams of electromagnetic radiation from their magnetic poles. He is the principal investigator of the Pulsar Timing Project, which uses the CSIRO's Parkes Multi radio telescope to understand the long-term behaviour of neutron stars and how they can be used to study the interstellar medium. Marcus is the lead author in a just published paper, Nature Astronomy, using the 64-meter Parkes radio telescope. So anyway, this is episode 192 on Astrophysics podcast. So at some stage in the near future, I will run this over for a Friday night session. Finally, we shall bump into spaceweather.com. Before I do have a video of the aurora that occurred 2 weeks ago now. This is from the from the All Sky camera up at the Dark Sky site at Heathcote, courtesy of Lee Green, and of course the Sky camera is located in the vicinity of the radio astronomy installation. The original All Sky Cam was a little bit on the low resolution side of things. It worked well for quite a while, had a few problems from time to time, but it was low res, outputting composite video. This camera is a new HD camera on screen now, and it runs for about 2 minutes actually. But for those watching the video, you'll see that it starts off at about 6 o'clock in the morning, goes through the day, and is it going? Hang on a sec, let me just restart that. Alright, there we go. I ran the video, it was already finished. Okay, so on the screen right now you can see this is starting at about 6 o'clock in the morning. It's got a lot of cloud cover during the day. It's been raining, so there's a bit of moisture on the dome of the camera. But we're zipping through the day pretty quickly, and at one stage there's a bird, for a split second you'll see a bird actually land on the dome of the camera and then take off. It's there for a moment. Also in the shot you can see the radio telescope, the 8.5 meter radio telescope there at the bottom of the image. It's part of the radio astronomy setup. So anyway, the sun's slowly moving to the west, and as the sun sets, the electronic iris of the camera slowly opens up and becomes more sensitive to the night sky. So now the sun is almost on the horizon. You've got those afternoon colours of where the wavelength of light is a bit longer. It's got those beautiful colours. There was the bird for a moment. We just saw the bird on the dome. And any moment now you'll start to see the aurora. There it is. So once the sun sets, you can see how the aurora just completely lit up the sky. You can actually see this a distinctive ring going right across the sky, and it's almost entirely over the Heathcote location. You can actually make out the Milky Way in the background. If it wasn't for the glow of the aurora, you'd be able to see how sharp a detail those stars are. And of course we're coming up to the morning, and the sunrise is about to come up any second. So that's the a time elapse of that day on the 12th of May. So it was rather interesting, rather an exceptional weekend with that solar activity going on. The Sky camera is easy to see. All you got to do is go to the ASV website. I've got it actually here on the screen as we speak. So that's the All Sky camera page. And if you go to the ASV website and go under the sections, click on the sections tab, go down to radio astronomy, and look for the All Sky camera, and you'll see the live image, as you can see right there, and the moon in the shot there as well at the moment. So it's good to see that up and running in HD. It's particularly good. All right, spaceweather.com, where are we? Okay. The solar wind is currently at 382.4 kilometers a second at a density of 1.92 protons per cubic centimeter. The disk of the sun is currently like this on the screen as we speak. So there's a number of sunspots there. The current sunspot number is 130, whilst the radio sun, measured at a wavelength of 10.7 centimeters, is down to 176 solar flux units. The coronal, not coronal hole, the current aurora over the Antarctica. That's what it looks like at the moment. So there's a reasonable green ring over the Antarctica at the moment. I suspect that people down in South Tasmania would be easily seeing a greenish glow in the sky, most likely, perhaps. But that's the current auroral glow over Antarctica as we speak. Right, continuing on, let's see. Geomagnetic Storm Watch, G1 minor class geomagnetic storms are possible on May 26. Let me just go back to camera. Alright, that'll do. Yeah, so minor G1 class geomagnetic storms are possible on May 26 with a CME might graze Earth's magnetic field. The CME was hurled into space on May 23rd at 0640 hours UTC by an erupting filament of magnetism near the center of the solar disk. Now this is an interesting little thing, article here that spaceweather.com's got. And I'll bring up this map of the United States. There we are. Have a look at this, ladies and gentlemen. What you are looking at here, rocks and soil electrified by the superstorm. Across the USA on May 10 and 11, skywatchers marveled at bright displays of aurora borealis during the biggest geomagnetic storm in decades. Little did they know something also was happening underfoot. Strong electrical currents were surging through rocks and soil. The biggest voltages along the US eastern seaboard in the Midwest were as much as 10,000 times normal. A map from NOAA and the US Geological Survey shows some of the hotspots during the early hours of May 11. Back in March 1989, voltages only a little stronger than the ones shown above in the map on the screen brought down the entire hydro-Quebec power system. The resulting Great Quebec blackout plunged millions of Canadians into darkness. This time, however, power grids stayed up. We haven't heard of any serious problems so far, reports Christopher Blatch of NOAA's Space Weather Prediction Center. Blatch leads an effort at NOAA to model geoelectric fields during solar storms. The map on the screen is a snapshot from a real-time display that takes into account the 3D conductivity of the Earth and ongoing geomagnetic activity. A computer at the Space Weather Prediction Center crunches the data to produce minute-by-minute estimates of electricity in the ground. He says, I started working on this in 2011 after NOAA Space Weather Workshop, where representatives from the power industry asked for a geoelectric field model. It's a collaboration between NOAA and the US Geological Survey and others. We now have a version that covers much of Canada and the United States. When researchers talk about geoelectric fields, they use units of volts per kilometre. Earth's crust naturally contains quiet time fields measuring as little as 0.01 voltage per kilometre. During geomagnetic storms, these values skyrocket. On May 10-11, geoelectric amplitudes exceeded 10 volts per kilometre in Virginia and 9 volts per kilometre in Upper Midwest, says Jeffrey Love, a key member of the collaboration of the USGS. These are very high. For comparison, we estimate that geoelectric amplitudes reached almost 22 volts per kilometre in Virginia during the March 1989 storm. This means that May 2024 storm was, electrically speaking, about half as intense as the storm that blacked out Quebec 35 years ago. That's too close for comfort. Although power companies have taken measures to improve the resilience of their systems, no one would welcome another storm as intense as that of March 1989. Real-time electric field maps are published 24/7 on the NOAA website. During the next geomagnetic storm, click here to see what's happening underfoot. So click here is a link. That's very interesting. That's quite fascinating. I don't know whether we have anything like that for Australia. Probably not. But that's probably worth checking out next time there's something happening, since it's in near real time. That's really quite a fascinating thing to find out. All right, I think that's about it. Planetary K index now KP267. The current KP index is 2.67, which is considered quiet. The 24-hour max KP is 4, which is considered as unsettled. I also have a picture of the latest cycle 25, solar cycle 25. That's where it is at the moment. If you're interested in following solar cycle 25, that's where it is currently, together with the sunspot number as well. So we're still reaching the peak. We're still got a little whiles to go to reach solar maxima. So there's lots of things afoot that can still occur. So things are still warming up, as they say. On that note, as of May 24, there are 2,349 potentially hazardous asteroids. All right, okay, I think that's about it for tonight. Thank you very much for hanging around and listening to my dulcet tones. And I hope some of those articles were of some interest to you tonight. This is VK3 Echo Kilo Hotel on behalf of the Astronomical Society of Victoria. We'll conclude tonight's session, but before we disappear, we shall take a listen on 80 metres and see if there's any stations wishing to check in. This is VK3 EKH listening on 3541.
VK3 Golf Lima. VK3 Juliet Romeo. This is VK3 KIS. VK3 BDA Bendigo. And VK3 XL. VK3 TJS. VK3 SBX, but check-in only, Clint. VK5 Whiskey. VK3 BSF, Clint. VK3 AMB, I'll just check in, Clint. Very good tonight. And catch you next week. VK3 BSF, Clint.
Yep, gotcha. All right, and I think there was a weaker station there too amongst all that. VK3GL, VK3JR, VK3KIS, VK3BDA, VK3XL, g'day Mike, VK3TJS, VK3SPX,